In this video, we're going to build on our basic Mono RGB example that we did, where we just looked at RGB, and now we're going to add luminance in. So if we load up our 4 files, which is our RGB, but also includes now our luminance, red, green, blue, and luminance. First thing we do is we want to screen stretch. Have a look. So Command A or Control A on Windows. So green. Let's rename these. Let's rename this to blue, green, L for luminance, red. What we're going to do is we're going to build an RGB image like we did in the basic Mono RGB example, and we're going to use our luminance as a separate luminosity layer. But we're going to process the RGB independently, and even after we've stretched, we're going to combine these images together. The reason being that we can process them separately. So for the RGB, this is going to be our chroma, our hue and our saturation. And then the luminosity is going to be our luminosity. And for the luminosity, this is where we want to see all the details. So any improvement in contrast is going to improve areas of the image that we can see and reveal. And ditto, if we want to add in any sharpness, we'll do it to our luminosity. So the first thing we want to do is our dynamic crop, just to remove all those stacking artifacts. So we go to Processes, Dynamic Crop, Reset, and we're just going to drag the sides of this rectangle in, as I say, to remove those stacking artifacts on the side of the image. So do fine. And now we want to drag and drop the same crop to all of the other images. The other images have been all registered together, so they all line up with each other. And then apply it to the last image. Okay. And let's do our channel combination just for the red, green, and blue. Combinations here. Red, green, blue. And just like before, we have our combined RGB. We reveal that with an STF using Command A or Control A. So a little bit, we're going to do something different here. So previously we didn't color calibrate, we just applied a background neutralization. With this example, we're going to do a full photometric color calibration. So we go to All Processes, Photometric Color Calibration. This process needs to plate solve, so it needs to know the coordinates for our image, which if we look to the search on that, 133, we get those. We need to set the focal length 530 and the pixel size, ASI 2600, so it's 3.76 microns. And again, this tool will do a background neutralization as well, or at least we can enable it. So we need to find what the upper bound is for our background. It looks like 0.07. So we have 0.07 here. We apply this to the image.
We'll go plate solve, download a catalog of known star colors, and cross-correlate that catalog. It's the colors, the real colors, with what we have in our image, and then adjust the RGB to match that as close as it can, so it doesn't fit. This will take a while, so I might fast forward to the end. So here you can see our fit, which looks pretty good. We were actually pretty close. We did make some adjustments. So there's a properly calibrated triangle and galaxy. Okay, we're going to stretch this now using histogram transformation. Again, it's a light stretch. Preview. And turn off the SDF. It's a mid-tone stretch, so we slide the mid-tone over to the left. It's our first stretch. Just down a bit. So typically I like to try and get the histogram in between these two first bars. And gradually lessen, smaller and smaller stretch. And then bring it back down by clipping. Okay, that's decent enough. Okay. Okay, so we have our stretched, color calibrated chroma data. So this is our hue and our saturation that we use for our final image. We might actually boost the saturation just a little bit and reset that. And go into curves. And reset, apply, and preview, and saturation. And we'll just boost the saturation just a little bit. When you apply a luminance to color data, you're going to lose a little bit of saturation, so you need to artificially boost it just a little bit. That should be okay. On the LRGB combine, there is a saturation slider that you can adjust, but we're just going to give it a little bit before we do that. I think this is good enough. I might actually apply a little bit of contrast to this as well. Small clip this curve. Like those colors. This is very similar to what we did in the basic Mono RGB. Okay, I think that's a good chroma. Okay, so this is our if you want a better word, chroma, our hue and our saturation, and now we want to look at our luminance. So we can close down or shade these green and blue and find our luminance. So the idea behind luminance is that for the same integration time, the signal to noise ratio should be much higher for a luminance than it is for the individual channels. Even if you were to combine the individual channels into a synthetic luminance, that luminance for the same amount of time will be, as I say, or have a much higher signal to noise ratio. For the luminance now, in terms of processing, I'll typically like to remove the stars, and then I can just work on either the nebulosity in the background if it's a nebula I'm taking a picture of, or if it's a galaxy, I can work on that without affecting the stars. So I'm going to apply a light stretch to our image first, and then remove the stars, and we're going to remove them with an on-screen, and then we can screen them back in at the end. So a light stretch again, histogram transformation, reset, either to the top level image, turn on our preview, turn off our SDF, and mid-tone stretch.
visible there. Okay, again, just a very light stretch. And now we're going to run, you have choices here. You can use StarNet++, which is free, or the StarXTerminator, which is paid for. Certainly with the latest versions of StarNet, the latest versions of StarXTerminator, I find it much better. So that's my tool of choice, but feel free to use StarNet if that's what you have. So with this, we do want to generate stars, and we do want to generate those stars as on screen. So I'm going to drag this over. This will take a while, so I'll fast forward. Okay, so that's finished. Here we have our starred image. Here we have our starless. So there's a couple of artifacts. I'm not too sure they star remnants or things they're galaxies. If we can mask those out. So we'll keep our stars. Just shape that. And we're going to work on the luminance. The core of the galaxy is not blown out. Typically, if the core was blown out, you might do something like a HDR multiscale transform. And here, I think we'll just do a little bit of local histogram equalization just to stretch out and give a little bit of contrast to that center of the galaxy. So first up, I think we want to create a mask. So you've got a couple of options to create a mask. You could use range selector here. Just looking at range selector, you've got sliders. You can drag these up and down. And you can create a mask this way. And range this way. So you can create a mask this way, and you can convolve that mask. That's not a bad way of doing it. I'm going to show you a script that I like to use called the game script. It's something that you have to download. It's free. I'll put a link in the description for these scripts. So the game script is very handy, especially for galaxies producing masks. So you can add an ellipsoid here. You can center that, and it's quite quick and easy to produce a nice mask as well. So center that and you drag the ellipsoid. And it's going to taper off to the side, so you want to make it a little bit bigger. That center area. Something like that looks good. And then we've got a choice here, the gradient mask is what I like. Click OK. And now we have a nice gradient mask. Now what masks do, if you're not familiar with masks, it allows you to, close down the preview, it allows you to mask out a certain area. So if to apply the mask now to this image, if I drag the little tab here over to the tab bar, we'll see now it's showing the mask. So red is now protecting whatever, and then as we get towards white, or not white, or as it's revealing what's in the background image, this is going to apply whatever process more to the center here, and then gradually less to the outside, and then the whole background is protected. We have options up here in our mask to either enable the mask, invert the mask, or show the mask. So if you invert the mask, it does the opposite. So now the galaxy is protected, and we could work on the background if we wanted to do some noise reduction just to the background. And we could do that using a mask, and we're not going to apply it to the central area of the galaxy. What we want to do though is work on the actual galaxy. So we want to work the mask, but then we don't want to show the mask. So now if I do my local histogram transformation, it's just going to apply it mostly to the center here, and then gradually out to the outer spirals, and then not touch the background. This is what we want. So if I load up LocalHistrogramEqualization, and this is a preview, so we can click on that. As well, for these previews, if you want to zoom in, there's a little button here. You can click on it and then select an area that you'd actually like to show. So we're going to work on this. So this is actually showing us, if we reset this, yeah, wasn't reset. You can see here that's probably a little bit, here's before, here's after. That's probably a little bit over the top. So we have a couple of options here. This amount slider will allow us to blend the original image in with the equalized image. So if we bring that down to maybe 50%, and here it's not as aggressive. It's looking good. I might bring the contrast down just a little as well. So it's kind of severe. Let's see what that looks like. Yeah, that's nice. We're just adding a little bit of additional contrast into the central region of that galaxy. I think that's good. I'm going to apply that to the full image, drag the triangle over. As it's doing that, the kernel radius size, this is the size of the detail that you want to address. So it just so happened that the default 64, that's kind of mid-sized regions, and it just so happens that that was what I want to target for this galaxy. If you have lots of small little nebulous areas that you want to enhance, you might bring this down to 32. And if you want to do a large scale, this might be 128, 196, something like that. You can do it multiple times as well if you want, so you can target the large scale and the small scale. I would say though, certainly for the small scale, if you have stars, you definitely need to mask them out. So in this case, we masked out the entire background and we have the stars removed, so we don't need to worry about that. Okay, so we can remove the mask. Well, let's not delete the mask, let's just remove it. We might need it. So let's go turn it off. Okay, I think this is looking good. What we might do is apply a little bit of a curves here, just to stretch out the contrast, and then we'll look at an LRGB combine. So first up is the curves. First transformation. Reset it, apply it, bring up our preview. And then here, we're going to apply a little bit of an S curve. Too much background, just down a little bit. Okay. I think there. And again, for the LRGB combine, just like we can adjust the saturation for the combination, we can also adjust the lightness. Just to get something close. So let's apply that. Now, first up, we want to add our stars back in. So I think we don't need this mask anymore, so I'm going to close it down. We're going to add our stars back in. To screen our stars back in, we're going to use a little bit of pixel map. It's not just a simple addition. We want to screen those stars in. So to screen the stars in, we need to invert both images, multiply them together, and then invert. It's a fairly standard operation. So 1.0 minus L, multiply that by 1.0 minus L stars, and all of that we want to invert. And we want to create a new image. Check, is that correct? That looks correct. Okay, so here we have our galaxy with our stars added back in. Close down our luminance now, close down our stars. And now we want to bring out LRGB combine. So if we go to LRGB combine, RGB combination, to apply this, we're going to put L in here. Let's label this L with stars. With stars. We're not going to apply the chromatic noise reduction right now. Just want to see what this looks like. These are the two sliders I was talking about, the lightness slider. This will affect the luminance, and then the saturation slider will affect the chroma, the hue and saturation that we're adding. So I'm going to apply this to the color image. Let's see what it looks like. Okay, that's pretty close. That's pretty good. And if I'm going to zoom in here and just give you guys a look. So before and after. So there's before, there's a lot more noise. Afterwards, I've tidied everything up. And what you can do is, and we're not going to do it for the intermediate section, is we could have on the starless galaxy applied a little bit of sharpening. That way you'll just sharpen the galaxy. We can play with that with the mask on as well. We can just sharpen parts of the galaxy and then apply that to the luminance, and then we'll have slightly sharper dust lanes. But I actually think that looks pretty good. I think we don't need to adjust anything. I think that's good enough. Okay, well, that's it for the video. I hope you enjoyed it.